Test of an air compressor lecture for Mechanical Engineering Laboratory 2. Introduction. So, compressed air at some pressure above atmospheric has many practical uses, a few of which are operation of small air engines and pneumatic tools, operation of air hoist, cleaning by air blast, tire inflation, every filling service station has an air compressor. Pag na-flat ka, simple, lalagyan mo ng hangin. Paint spraying, airlifting of liquid, and many other specialized industrial application. So, reviews. So, types of compressor. Compressors are of two general types, the reciprocating piston in cylinder and rotary. The number of rotary type in operation predominate. In order to gain some familiarity with the mechanism of each, several compressors are shown in figures that follow. Figure 1 to 6. So figure 1 is a two-stage air-cooled compressor. So ito yung itsura niya. So hindi tayo mag-discuss ng parts. Operation yan. Maintenance. So ito yung cylinder. High pressure. So splash drive pin. Intercooler. So yan tubo. May tubo yan. Tapos may pins. Okay. Ito naman, pins naman to. Kadalasan to is yung sa mga transformer, di ba? Pins yun. Pag uminit siya, so dito ma-absorb. Next is the centrifugal compressor for supercharging. So thermobook lang to. Keepers. Then diffuser and impeller. So ito yung loob ng compressor. Okay. So figure 4 is a two-stage water-cooled compressor. So andito yung compact intercooler. So andyan yung heat exchanger niya. Andyan yung water cooling. Ito yung cylinder, yung valve. So, number 5, positive displacement blower. So, asan yung ito yung piston. Next is the sliding blade compressor. So, walang cylinder. So, hindi. Ito yan, sliding blade. Maraming type ng compressor. Ito yung rotary. Now, compressor work. So, since this is laboratory, itong lecture na to is pang introduction lang. O, dito nyo makikita yung mga parameters na kailangan sa testing. If the compressor is of rotary type, so figure 2, it would be treated as a steady state, steady flow system with flow through the control valve whose boundaries are at the intake and discharge. And typical is rotary. Diba? Yung piston cylinder and yung reciprocating. Okay, apply the steady flow equation with negligible energy terms deleted. Yung mga potential, wala yan. Energy, kinetic energy. Let the mass that enters and leaves be represented by M prime if a particular rate is considered. Then, the work is equal to delta S equal to negative M prime times Cp times T2 minus T1 is equal to negative M prime Cp times T1 times T2 minus T1 over T1 minus 1. Okay, M prime kasi yan yung enters and leaving, entering and leaving. Kasi mayroon pang mass yan sa loob na naiiwan. Okay? Mamaya, malalaman natin yon sa clearance volume. So, wait, kasi meron tayong A and B ito. Okay. Magalaw. So, ito pala yung B. Introduce into A, the values in B, and get equation C. So, C is equal to CP as KR over K minus 1. So, di ko na ito, kung sabihin ko ano to. Ito yung mga sa termo nyo. T2 over T1 is equal to P2 over T1 is equal to K minus 1 over K. P1 B1 prime is equal to M prime RT. So the work is K M1 M prime are T sub 1 over 1 minus K times P2 over P1 exponent K minus 1 over K minus 1, or K times K P1 B1 prime over 1 minus K times P2 over P1 exponent K minus 1 over K minus 1, where B1 prime is the volume measured at P1 and T1 corresponding to mass M1 M prime. A similar approach to steady flow polytropic yields an equation of the same form, only N is in place of K. Palitan mo lang yan. So ito yung figure 7 natin. Yan. This is a gas engine compressor. So ito yung diagram niya. Maulit yan sa kabila to. So yan. If the compressor is reciprocating figure 7, the events within the cylinder are described in figure 8. So derivation is yung reciprocating, pero sa actual pwede rin to sa centrifugal. Okay? The events within the cylinders are described in figure 8. Yeah. So ito yung events. Conventional diagram for compressor. Okay? Wait. Pahinga muna tayo. So dito sa figure 8, an idealized picture of the variation of P and B in the cylinder. Start at 4. So 4 represent the intake and is called the suction line. Dito. Then 1 to 2 represents intake, papasok to. Siyempre yung mass mo, meron siyang giving volume dito at yung mass na clearance volume. Pag nag-intake ka, so tataas yung volume. Naglagay ka ng M prime, nag-flow. So ito na yung flow mo, B sub 1 prime. So mag-i-increase yun. So that is the intake. So 1 to 2, all valve close, and there is some kind of thermodynamic compression process dito. So this is PB upon K is constant. That means entropy constant. Okay. Then 2 to 3 is the discharge, the piston pushing the gas from the cylinder through the open discharge valve. So yan dito, discharge na siya. Okay. So pag discharge siya, siyempre liliit yung volume matitira. So ditong 3 is the clearance na to. So yan yung pinakasagad. Yan. So ito yung talagang process mo. Compression process is 1 to 2. Ito yung sa naiwan na process. Okay? So 3 to 4 is an expansion of the gas left in the cylinder's clearance space. A clearance between the piston and cylinder head at is a necessity. Notice that the greater the clearance volume, B3, the less gas from blown in 1. Yan, sa mga compute natin. Now, the total work on the gas is, if first we imagine the compressor with 0 clearance, work is done on the piston from A to 1 by the constant pressure gas at P1. Work is done by the piston from 2 to B on the gas at P2. So the total work done on the gas is now seen to be the integral of B, P, dP. So the area behind the curve 1 to 2, that is, this integral accounts for the work of drawing in, compressing non-flow, and discharging the gas. By the same logic, the area B3A to is also negative B dP. Negative to, dito yung minus. Yan. Negative yan. Dito yung minus. But of course, for a different mass, since areas on BP plane represent energy, the area enclosed 1, 2, 3, 4 represent the work of this conventional compressor. So we find negative the integral of 1 to 2, so B dP is equal to K times P2 minus P1 minus P2 B2 over 1 minus K, or K P1 B1 over 1 minus K times P2 over P1, so K minus 1 over K minus 1. Okay? Where B2 over B1 is equal to P1 over P2 is 0.1 OK was used in the bracket. Yun. Okay. So this is the work. Observe that this equation is of the form as see above. The same final form naturally applies to process T to 4. Yeah, sa expansion. Figure it. Therefore, an algebraic sum gives the enclosed area the work of the diagram. So, however, to avoid some extra algebra, we shall subtract 4 to 3 instead of adding 3 to 4. For the 4, equation 4 to equation 3 instead of adding into 4. So, yan. So, W is equal to okay, equation number 2, equation number 2. So W is equal to K B1 over 1 minus K times P2 over P1 from K minus 1 over K minus 1 minus K P4 B4 over 1 minus K times P3 over P4 over K minus 1 over K, so minus 1. Okay. So the work is K P sub 1 times B sub 1 minus B sub 4 over 1 minus K times P sub 2 over P sub 1 K minus 1 over K minus 1. So equal is equal to, so ito nag-minus na to. So yan. So this is now the B prime. So di ko nabasahin to. Yun na rin yun. Okay? Ang ibig sabihin nito, however, to some about some extra algebra, simple, yung summation, mag-add ka. So since negative to, so mag-minus na lang yan. Since P4 and P1 and P3 is equal to P2, for B1 minus B4, the volume of gas drawn in, we can use B1 prime. And it will often be convenient to let P1 B sub 1 prime is equal to M prime R T1. So yan. Whereas possibly defined M plus is the mass of gas passing through the compressor. Now, if the processes 1 to 2 and 3 to 4 are polytropic with the same value of N, substitute N for K, italics, in equation 1 and actual indicator card is shown in set of figure 7. So if the compressor is in 2 or more stages, figure 1 and 4, the work of conventional diagram for each stage is given by equation 1, where P2 over P1 is the pressure ratio for that stage, and P1 and B1 prime are measured at particular stage intake. Figure 1 and 4. Sa water-cooled compressor, 2 stage, yan. Saka figure 1, 2 stage. Saka ito binanggit. Eh, wait lang ayusin lang tayo. Next, the prepared compression curve. Ano lang tayo pa? Single stage lang ito discuss. In as much as the asymptotic curve 1 to 2 prime, figure 9, is steeper than the isothermal on PB plate, it takes more work to compress and deliver a gas when the compression is adiabatic than when it is isothermal. The difference being represented by the shaded area. So ito isothermal 1 to 2 and 1 to 2 prime is the isentropic. Compression curve with values of N between unity, isothermal, and K will fall within the shaded area. Thus, it is obvious that the work necessary to drive a compressor decreases as the value of the exponent N decreases. Polytropic compression and values of N less than K are brought about by circulating cooling water or air around the compressor cylinder to conduct away some of heat generated by the compressor work. In a small, inexpensive compressor of the type found in automotive service center, the cooling is always inadequate. Values of N will be 1.35 or higher. Under favorable circumstances, a value of N 1.3 or less may be expected. Values of N from 1.25 to 1.3 represent the best result for water-jacketed compressor. So, i-change nyo na lang. Pag ma-mention tong mga water-jacketed compressor, so ang value ng N mo is yan. Pero ngayon, asymptotic muna tayo. So, example number 1. Air compressor work. A rotary compressor receives 6 cubic meter per minute of gas. So R is 410 joules per kilogram Kelvin. Cp is 1.03 kilojoule per kilogram Kelvin. K is 1.67. So, and 105 kilopascal absolute, 27 C, and delivers it at 630 kilopascal. Delta P equals 0. Delta K is 0. Find the work if the process is A, asymptotic, B, polytropic with PB is 1.4, PB exponent 1.4 is constant, C is isothermal. Okay? So, baka sabihin yung PB 1.4 isentropic, hindi. Kasi sinabi dito, gas na ang R value is 410 joules per kilogram Kelvin. So, hindi siya air. Ang K mo dito is 1.67. So, given the volumetric flow rate 1 is 6 cubic meter per second. So, considering na ito na yung V1 prime mo. Diba? Huwag mo nga natin anuin yung clearance. R is 0.410 kilojoule per kilogram. Cp is equal to 1.03 kilojoule per kilogram Kelvin. K is 1.67. Okay. So, ang problem, sabihin ng state 1 is yun nga, V1. So, pag talagang process na is meron siyang clearance doon, i-minus mo yun. Yun yung required na in and out. Yung mass mo dito, ito yung nag-circulate na kasi may kasama na may dating na isang mass sa loob. Okay? So, R is 0.410 kilojoule per kilogram Kelvin. Cp is 1.023 kilojoule per kilogram Kelvin. K is 1.67. P1 is 105 kilopascal. T is equal to 27 plus 273 is 100 Kelvin. P2 is equal to 630 kilopascal. So, alisin mo natin itong minus sa may T1. Pause mo. So, required is the work by asymptotic, B polytropic with PB exponent 1.4 is C isothermal. Solution for all parts ABC, use the steady flow equation, energy equation. Steady flow equation is Q minus delta H. So A, isentropic work, PB exponent K is equal to C, Q is equal to 0. The isentropic is Q is 0. Q is temperature times delta S. Okay? So the mass is equal to P1 B1 over RT1 or 105 times 6 by 0.41 over 300 is 5.12 kilogram per minute. Okay? SI to. Kaya ganyan kasimple. Then T2 is equal to T1 times P2 over P1. Exponent K minus 1 over K is 300 times 630 over 105. Exponent 1.67 minus 1 over 1.67. So T2 is 615.6 Kelvin. So the work is equal to negative of delta H. Negative of mCp times T2 minus T1. So negative 5.12 times 1.03 times 615.6 minus 300 is negative 1664 kilojoule per kilogram. Answer. Also work is equal to Kp1 B1 over 1 minus K times P2 over P1 exponent K minus 1 over K minus 1. So substitute values is 1.67 times 105 times 6 times over 1 minus 1.67 times 630 over 105 exponent 1.67 minus 1 over 1.67 minus 1 is negative 1652 kilojoule per kilogram answer. So, para siya na yung 1664, 1652 approximately equal. Nag-difference lang siya dito. Kaya sa anong dahilan yun? Bakit nagkaiba? Kasi yung CP. CP. Pag ginamit mo yung CP is equal to R over K minus 1. So, approximately, mag-i-exacto sila. Okay? Ginibi niya kasi yung isa pa. Okay? Eta. Dito. Okay. Ano lang. Tama, tama. So, next, letter B. Polytropic work PB exponent N is equal to C. So, N dito is 1.4. So, T2 is equal to T1 times P2 over P1 is N minus 1 over N is 300 times 630 over 105 and 1.4 minus 1 over 1.4. So, N is 1.4. Okay? Cn is equal to Cb times K minus N over 1 minus N is equal to 0.617 times 1.67 minus 1.4 over 1 minus 1.4. Okay? Saan galing yung 0.617? Ito. So, di pinakita dito. Ang CB is equal to R minus, CP minus R. Okay? CP minus R is CB. So, 1.03 minus 0.41. Thank you. Ayan. That is 0.62 or 0.617. Okay? So this now, Cn is equal to negative 0.416 kilojoule per kilogram. Ba't in-example nyo to? Yan. Or R over K minus 1. So 0.41 divided by 0.67. So this is 0.612. Okay? So yun ang formula, di ba? So this is work is equal to negative M Cp times T2 minus T1 plus M Cn times T2 minus T1. Tama? So, isobaric mo less yung constant pressure. This is 1 is the change of enthalpy and Q. Okay? Then nyo works equal to negative Q plus the negative enthalpy. This is Q. Enthalpy and wait na. Okay, balikan natin. Work. So Q is equal to steady flow work plus delta H. Ina-explain dito. Okay? Okay. So this is now work as this is negative of change of enthalpy plus the heat. Okay? So it's equal to M times Cn minus Cp times T2 minus T1. So work is equal to 5.12 times negative 416 minus 1.03 times 500.5 minus 300. So the work is negative 1484 times kilojoule per minute, or the work is N P1 B1 over 1 minus N times P2 over P1 times N minus 1 over N minus 1. So 1.04 times 105 times 6 over 1 minus 1.4 times 630 over 105 times 1.4 minus 1 over 1.4 minus 1 is, the work is negative 1474 kilojoule per kilometer minute. So approximately siya equal. As kahit alin dyan ang gamitin mo. C, isothermal work, PV is equal to C. So T2 is equal to T1 is 300 K, and delta H is equal to 0. So Q is equal to delta H plus W. Since delta H is 0, so the work is equal to Q. So the work is equal to P1 B1 ln of P1 over P2 is 105 times 6 times ln of 1 over 6 is negative 1129 kilojoule per minute. Yun. So note that, yan ang answer mo. Note that the cooling of the gas during compression lowers the work requirement. Yeah. Ito, tingnan mo. Work is now is equal to Q. Ibig sabihin ng pinapalamig mo yung gas, sabihin nagiging constant temperature siya. Diba? So walang losses. Next, free air. That is free air. Normal, mga compressor, binibigay siya is 1,000 CFM. Free air yan, free air. At yung CFM mo at that air condition. So ambient. Pero sa supply mo, ng compressor, mataas ng pressure. Okay? So bababa yung flow mo. So na-compress nga siya, di ba? So iba naman yung CFM doon. CFM at that pressure. Okay. Now, pre-air is at normal atmospheric conditions in particular geographical location. Since both pressure and temperature vary with altitude, a compressor designed and adjusted to deliver a particular mass of air at a certain discharge pressure from a sea level location will not deliver the same mass when intake is at 7,000 feet location. Also, without valve changes, the delivery pressure will be lower. Thus, the compressor or a jet engine inducts and delivers less mass of air at high altitudes than at low altitude. So the variation of the NASA USA standard atmospheric pressure is given in figure 10. The NASA standard temperature varies linearly from 59 at sea level, 40 degrees altitude to negative 67 at 35,332 feet altitude. So this amounts to 0.003566 feet per foot, or the rate of the slope of the pressure of T with respect to C is 0.003566. Okay? So other books, meron din silang approximation, pero ito ang value. Linear. So tingnan mo yung slope ganyan. Okay? Sa NASA. Wait na. So, sorry, this is 40 degrees latitude. Next, important terms sa testing is yung volumetric efficiency. So, consider that again, figure 11, conventional diagram. Sa figure, observe that if state with is coincident with 2, and 1 and 2, and if 1, 2 were an internally reversible process, the expansion 3 to 4 would coincide with 2 to 1. So if it were the same kind of process and internally reversible, same end in this case. So the volume swept by the piston and one stroke is B1, B2, called the displacement volume. Yun. Yung displace lang ng piston. Hindi naman lahat kasi meron ngang ito. May laman siya. May laman dito. Puno to ng hangin dyan. Tapos nag, ano siya dun na. Tapos dito, discharge na. So, bababa yung pressure mo as is yung piston mo. Okay. So, tapos, pagdating dito, so mag-expand siya. Tapos saka napapasok naman yung gas, pupunta naman doon. So, since a reciprocating compressor has a clearance of volume B3, so the volume of gas intake is always less than the displacement volume of the piston. The larger the clearance volume, the less gas discharge. The actual volumetric efficiency, and so B, is the actual volume drawn in at P-T, say as measured by an orifice at intake, divided by the displacement volume at dimensionless ratio. So, since for displacement volume, we may say the volume of gas at P sub O T sub O would occupy the mass displacement B sub D. The ratio as defined may be stated in terms of mass. So, the volumetric efficiency is the ratio of mass N divided by mass D. So, mass drawn N C per stroke per or per minute. Mass at P sub O T sub O that would occupy P sub D divided by, which is sometimes the more convenient definition. So the conventional volumetric efficiency, that is from the conventional diagram, figure 11, is B sub 1 prime over B sub D. Okay. So B sub 1 is equal to B sub 1 minus B sub 4 divided by B sub D. The ratio, the clearance ratio, C is equal to B sub T over B sub D. Yan. Or B sub T is equal to C BD. So then, equation B sub 4 is equal to B sub 3 times P sub 3 over P sub 4 exponent 1 over N is equal to C times B sub D times P sub 2 over P sub 1 exponent 1 over N. Or C times B D is equal to B1 over B2. Since the total volume B sub 1 is equal to BD plus C plus BD, we have N sub B is equal to B sub 1 minus B sub 4 over B sub D is equal to B sub D plus C times B sub D minus C plus B sub D times exponent of P sub 2 over P sub 1 exponent 1 over N. So the volumetric efficiency N sub is equal to 1 plus C minus C times P sub 2 over P sub 1 exponent 1 over N is equal to 1 plus C minus C times P sub 1 over P sub 2. Okay? Ito ang kailangan nyo rin i-memorize. So, if the compression process is isometric, let N is equal to K. So, the actual volumetric efficiency may be, next, the actual volumetric efficiency may be much lower than the conventional because of fluid friction of flow. The pressure in the cylinder is less than the temperature of the free air and the pressure of the free air. And because the cylinder walls being relatively hot, heat the incoming air, less mass of hot air can occupy a given space. Next, displacement volume. Yan, madalas kinukuha natin ano yung diameter, bore and stroke ng cylinder. Kahit sa diesel, ganun din to, di ba? Diesel engine. Sa engine, may cylinder. Sa reciprocating. So, okay. The displacement volume, B sub D, corresponding to one diagram as in figure 8 or 11, yung nakikita niyang B sub D doon, B sub 1 minus B sub 2, is the volume swept by the piston in one stroke. FD is the diameter of the cylinder and L is the length of the stroke of the piston. B sub D is equal to pi D squared over 4 times L. If the engine is double acting, so yung cylinder mo, kabila, may piston, di ba? May connecting rod. Yung kabila, wala. So, ganun lang. Pero both side, may laman. Nag-exert sa on opposite, alternate. So, if the double acting, engine is double acting, a diagram is made on each side of the piston. While a compressor diagram is completed in 2 stroke or 1 revolution. Yan. So, 2 stroke is 1 revolution. Forward and backward. Diba? To complete a diagram, some internal combustion engines takes 4 strokes to complete a diagram and in addition are multi-cylinder. Okay? Muna tayo, compress air. Since it is open convention to express the displacement volume in cubic feet per minute, multiply the displacement for 1 stroke by n diagrams per minute. CFM per or cubic feet per minute. So, B sub D is equal to pi D squared over 4 times L cubic feet or BD is equal to pi D squared over 4 L N CFM. Determine the value of N to accord with the actual engine being studied. Nakukuha naman yan sa actual. So, there are next, compressor efficiency. So, yung mga parameters na kailangan nyo. So there are a number of defined efficiencies of compressor, basically of the form and sub C as ideal work divided by actual work. The difference being in where the actual work is measured and what is ideal work is the standard comparison. So unless we define it otherwise locally, we shall use the adiabatic compressor efficiency, which is the isentropic work divided by the actual fluid work, or H1 minus H2 isentropic by S1 minus S2 prime sa figure 12. So papunta uli siya sa left, sa right side. Hindi papunta dito, where for steady flow condition, it is presumed in equation 4 that the kinetic energy change is negligible, where the numerator is negative delta SS for an isentropic process and the denominator is actual enthalpy change, say along the adiabatic 1 to 2 prime. Okay? Bakit? Wait, So, numerator is delta HS. Yung nakalagay dun eh. Basta yan. Same naman ang unit yan. Equation 4 is applied to reciprocating compressor when W prime is the actual work of an indicator diagram or the shop work. So, example number 2, air compressor. A 14 by 15 inch double acting air compressor whose clearance is 4% runs at N150 RPM. At state 1, figure 13, so yun. The air is at 14 PSI and 80 Fahrenheit dito. Discharge is at 56 PSI. So dito. So pressure niya, constant pressure naman yan. Compression and expansion are isentropic. So yan. So both are K. The state of the surrounding atmosphere is PE is 14.7 PSI and TA is equal to 70 Fahrenheit. A is the estimate the amount of free air CFM using the conventional volumetric efficiency. B, compute the horsepower for a compressor efficiency of 75% based on work input. Given, so D, bore 14 inches, length is 15 inches. This is a double acting. So C is 4% or 0.04. P sub 1 is 14 PSIA. T sub 1 is 80 plus 460 Fahrenheit, 540. P sub A, atmospheric, is 14.7 PSIA. P sub B is equal to 70 plus 460 or 530 Rankine. Required is the A, amount of free air, CFM, B, amount of horsepower. Sa industrial nyo, mabalik din to kasi meron dong compressor system. Mga sizing ng compressor. Solution. Since one diagram is completed by each side of the piston, one revolution for double acting piston and one revolution for double acting engine, there are 2 diagrams per revolution. Diba? Dalawang, and N is equal to 2N is equal to 150. So 2 times 150 is 300 diagrams per minute. Okay? Alright. So A, amount of free air. So B sub D prime is pi D squared over 4 times ln. So pi times 14 squared times 15 times 300 over 4 over 1728. Saan galing yung 1728? 14 is in inches, 15 is in inches, lalabas is cubic inch. So there are also 1728 cubic inch per cubic foot. Okay na? So B sub D is equal to 401 CFM. So N sub B is equal to 1 plus C minus C times P sub 2 over P sub 1 plus 1 over K, or 1 plus 0.04 minus 0.04 times 56 over 14 is 0.1 over 1.4. So N sub B is equal to 0.93 to 93.2%. So now the volume drawn in as measured at state 1 is B sub 1 prime is N sub B sub D is 0.93 to times 401 is 374 cfm. Okay? The state 1. This is yung condition ng P1, B1. So, i-convert mo siya sa PA, BA. So, BA prime. So, measured at PA, TA, the volume of free air is B sub A prime is equal to P sub 1, B sub 1 prime, T sub A over T sub 1, P sub A. Therefore, 14 times 374 times 530 over 540 over 14.7. So, wala tayong magko-convert dyan, ha? So, hindi naman kailangan. So, it is equal to 350 CFM. So, this is now the answer. Now, the horsepower. So, the mass prime is PB1 of prime over RT1 is equal to 14 times 144, yung conversion yan, times 374 divided by 53.3, yung air, by 540 is 26.2 pounds per minute. Also, T sub 2 is equal to T sub 1 times P sub 2 over P sub 1 K minus 1 over K. So, T sub 2 is equal to 540 times 56 over 14 times 1.4 minus 1 over 1.4 is 802.4 Rankine, or T sub 2 is 342.4 Fahrenheit. Okay? So, din mali Fahrenheit ang final answer dyan. Kung ano ang given sa ano, yun din ang sagot mo. Fahrenheit ang given, Fahrenheit din mga temperature mo. Diba? That's it. So, now, kinuha natin yung kasi itang formula ng work. Work is equal to negative delta H is equal to negative M prime CP times T2 minus T1. So, this is now negative of 26.2 times 20.24 times 802.4 minus 540, or negative 1650 BTU per minute. Sa sign convention, ang work is laging sa compressor work is laging negative. Okay? Kasi nasa ano siya, Q is equal to delta U plus work. So, yung work doon, out. Di ba? Output. A compressor input, kaya negative. Okay. So, the work is equal to N, P sub 1, B sub 1 over 1 minus N. Another equation to times P2 over P1 times N minus 1 over N minus 1 is 1.4 times 14 times 144 times 374 over 1 minus 1.4 divided by 778 foot-pounds per BTU. Okay. So, 56 over 14 times 1.4 minus 1 over 1.4. So, this is now negative 1648 BTU per pound. Check ko lang kung 1.4. Ito kasi 14 nakalagay. Okay, wait . So, ito yan. Now, in horsepower, work over the compressor efficiency is 1650 BTU per minute. Absolute value divided by 0.75 over 42.4. So, 42.4 is a conversion naman. Okay? So para yung BTU per minute, maging horsepower. So this is na 51.9 answer. Kasi normally, ang horsepower is a unit of work, power. Nga, ang BTU per minute is a unit of heat. Kaya dito, i-convert mo siya sa horsepower. Ang kilowatt, walang problema. Pag sa English units, hindi mo maano kasi yung BTU in sa work. Kasi ito is thermal unit. Ba? Yes. O yan, horsepower. Pakalagay naman. So, other efficiencies. So, in addition to volumetric efficiency and compressor efficiency, there are several other efficiencies that are pertinent to the compressor. So, mechanical efficiency is defined by the Compressor and Gas Institute or CAGI in two ways. One, when the drive is by internal combustion engine or by reciprocating engine. So, N sub O is equal to N sub M or N sub C. So, N sub M is IHP of the compressor divided by IHP of the driving machine. An expression that applies to the unit. Or two, when the drive is by electric motor. That is IHP of compressor divided by the BHP of compressor. Okay. So the frictional power of the compressor proper may be estimated by empirical equation. So wait, nawawala. So yan, ito pala. Tumaas to. Okay? So dito ulit, ISP of the compressor, ito yung actual required ng compressor mo. Diba? Tapos, siyempre, yung source mo, magbabawas yon. So, ito na yon. BHP of the compressor. Diba? Doon matapos ano sa dito sa electric motor, may mga shafting, mga ano, magbabawas magiging ISP. So dito ganoon din, pero ang tawag doon hindi sa motor. IHP naman 'yon, ng driving machine or internal combustion engine or by steam engine. Okay, paras lang. Yung ano ito yung source mo. So deflect ito naman sa motor na to, pipili ka na. So the frictional loss power of the compressor proper may be estimated by the empirical equation. So where B sub D is equal to the piston displacement in CFM. This friction loss power is yung difference niyang numerator, denominator. Another efficiency similar to compressor efficiency adiabatic is defined as the isothermal compression efficiency kung siya ay isothermal. Ideal work divided by actual fluid work. A value that often falls within 70 to 75%. And the isentropic, the overall efficiency and so is the product of the mechanical efficiency and the particular compression efficiency, adiabatic or isothermal, where efficiency N sub O is equal to N sub M times N sub E, is where efficiency based upon adiabatic compression are usually favored. Okay? Pero kung may motor efficiency, genset efficiency ka, so multiply po rin dito para maging overall. Kaya overall, wala nang ano pa dyan, sobra. Laging dito multiplier. So, ang tawag pa rin sa kanya is overall. Next, multi-stage compression. So, ito na, yung may mga intercooler. Okay? Multi-staging is the compression of the gas in two or more cylinders in place of a single cylinder compressor. It is used in reciprocating compressor in order to save power, limit the gas temperature, and limit the pressure differential per cylinder. The latter reason is very important because volumetric efficiency not only is affected by clearance, but also by the pressure ratio across the cylinders. Equation 2. Moreover, excessive high temperature caused by compression of the gas to high pressure may cause difficulty in the internal lubrication of the cylinder and piston. Finally, Mass power can be saved through multi-staging if the discharge pressure is above 75 psia and if the displacement is above 300 cfm. Study figure 14 and read caption carefully. Ito yung limit niya. Pag nagbaba niya, so hindi, yung multi-staging, hindi na advantageous. So dito, 75 psi sa displacement, advantageous siya kasi makakasave ng power. So ito yung figure 14. Conventional card for two-stage compressor. So NA. Okay, picture the figure 14. So NA dito, without pressure drop in intercooler. Yan ang diagram niya. 1 mgh 1 mgh outlines the conventional card for single compression to P4 for a given percent clearance. If the percent clearance is the same in both cylinders, the expansion in the high pressure cylinder start at some point F instead of G. Yan. So ito 1 mds is just an outline. Okay? So now if percent clearance is the same for both cylinder, ito yung clearance nitong cylinder na to, ito naman yung low pressure cylinder. Ang clearance na ito. Okay? B sub B is C, B sub DL. Ito. Then DH, L is low pressure, H is high pressure. So yan. So B sub F is CBD. Okay? Yan. Oh. The expansion in the high pressure cylinder starts at some point F instead of G. Yan, so two-stage. For a two-stage machine, suction starts at A. Our expansion and low pressure cylinder starts at B, where B is equal to BG. Okay. For a two-stage machine, suction starts at A. For a single-stage machine, suction starts at H. Di ba? Magkakaiba niya. The capacity of the two-stage compressor is greater than that of a single stage by the amount of BH minus BA. Observe that it is possible to make the clearance so large that no air would be delivered. As a matter of fact, varying the clearance is an efficient manner of governing the output of the compressor. The work saved by the two-stage compression is represented by the shaded area 2 and 3. Yan, kita niyo shaded area. So, yan yung nawalang work. Since there is some pressure drop during flow over to the intercooler, the conventional card may show this drop as in B. So, figure B. The shaded area between B and T B represent lost or repeated work due to this pressure drop. So, yan. 1, 2, 3, 4. So, 1, 2. Imbes na sa pantay siya, yung 3 mo, kasi ito yung drop mo dito, pressure drop. So, dyan sa mag-start, baba. Ayan. Okay? That is two-stage. So, it is common practice to cool the gas between stages of compression in an intercooler. So, yan. This is the intercooler. Figure 1, figure 14, and 15. And it is this cooling that affects considerable saving in power. So, ito ulit. Mas na dalawa to. Previous. Okay. So figure 14 shows the event of conventional indicator cards of two-stage machine with the high pressure SP superposed on the low pressure LP. Superposed na patungan. Suction and the LP cylinder begins at A. Ito. And the volume B1 prime is blown in. Compression 1 to 2 occur and the gas is discharged along to B. The discharged gas pass to the intercooler and is cooled by circulating water through the intercooler tubes. Yan. Conventionally, it is assumed that the gas leaving the intercooler and entering the high-pressure cylinder has the same temperature as it had upon entering the LP cylinder. So, ibabalik mo sa temperature. See state point 3. Stop. So, ito yung constant temperature. So, yan. Balik siya sa temperature. So, the gas is then drawn into LP cylinder along 3E. Yan. Is compressed 3 to 4. Walang suction dito, walang suction. Okay, and finally discharge from compressor unit for F. Note the residual gas always remain in each cylinder because of clearance and mass expand FE. Yan, remains. And BA sa low pressure. Ba? Gets nyo? Two-stage yan. Equation 1, kanina, gives the work of an indicator card like 1, 2, BA, or 3, 4, FE. So we simple add the LP work to the SP work and have W is equal to NM prime R T sub 1 over 1 minus N times P sub 2 over P sub 1 point N minus 1 over N then minus 1 plus NM prime R T T over 1 minus N times P4 over P3 N minus 1 over N minus 1 for two polytropic compression processes. Same end. It is common practice to adjust the operation of multi-stage compression so that approximately equal works are done in the cylinder. A practice that results in minimum work for compressing a given amount of air. So thus, for the particular case of T1 is equal to T3, yan, and P2 is equal to P3 and Pi intermediate pressure. Say we have the work of LP stage equal on the SP stage or NM prime R over T1 1 minus N times Pi over B1 and N minus 1 over N minus 1 is 6 N M prime R T1 over 1 minus N plus P4 over Pi is 0.N minus 1 over N minus 1 from which we find Pi over 1 is equal to P4 over I or Pi is equal to P1 P sub 4 is 0.5 where Pi is the proper value for the intermediate pressure for condition specified. Okay. So, yan. More on more practice, may mga intercooling. Okay. 3 to 4 intercooling stages. Hindi tayo makabigay sa mga books na lang. Reviewer. So also, since the work of each cylinder is the same, the total work of for the two machine is twice the work in either cylinder. Or the work is 2 N M prime R over T1 1 minus N times P2 over P1 is point N minus 1 over N minus 1. Or yung ratio ng pressure is P4 over P1. Okay? An equation that applies only when T1 is equal to T3 and P2 is equal to P3 as in bound and B. Okay? For 3 or more stages of compression, more than 3 stages are uncommon. So, hindi na. So, the methods of analysis is similar to that given for the two-stage machine. Yeah. So, makita nyo lang to sa mga problem solving. So, if an intercooler, figure 15, is analyzed as steady state, steady flow, steady state device. An equation is obtained that gives the transfer heat, whether the process is reversible because or irreversible with pressure drop. Consider the steady state, steady flow energy equation applied to the intercooler process BE, shown in figure 14. So HB plus KB plus Q is equal to HA plus KB plus W. For the process work, W is equal to 0, delta K is equal, it follows that Q is equal to HE minus HB is equal to delta H. So, since we are analyzing the compression of gas, Q is equal to M prime Cp times Te minus Tb, where M prime is the mass of gas passing through the intercooler, also the mass drawn in by LP cylinder and delivered by the SP cylinder. Okay? So example, two-stage compressor. A two-stage compressor, double-acting compressor, operates at 150 RPM, takes in air at 14 psi A, 80 Fahrenheit. So the LP cylinder is 14 by 15 inch. The stroke of each cylinder is 15 inch and the clearance of both cylinders is 4%. Air is discharged at 56 psi A from the LP cylinder, passes through the intercooler, and enters the SP cylinder at 53.75. And 80 Fahrenheit. It leaves the HP cylinder at 215 psi. The polytropic exponent N is 1.3 for both cylinder. Neglect effect of piston not on the crank end. Environmental atmospheric conditions are 14.7. Piston dahil sabihin, pag-compute mo ng volume, wag mo nang i-less. Okay? So, find A, wala ka naman pala i-less. So, find A, the volume of pre-air compressed. B, heat transferred during compression to cooling water around the LP cylinder. And C, the heat rejected during intercooling. D, diameter of each cylinder. And E, the work required by for the compressor. It lang. So, given DL is 14 inches yung low pressure. L is 15 inches. C, 4% as equals to 0.04. P sub 1 is 14 psi A. T sub 1 is 80 plus 460 or 540 Rankine. P sub A is equal to 14.7 psi A. T sub A is 70 plus 460 or 530 Rankine. P sub 2 is 56 psi A. Ayan, ito yung TS diagram. Ito yung PV diagram. 2 to 3 is intercooling na may pressure drop. Polytropic is N is 1.3. N is 2 times 150 RPM is 300 diagrams per minute for double acting. So required, A, the volume of pre-air compressed. B, heat transfer during compression to cooling water around the LP cylinder, low pressure. C, heat rejected during intercooling. D, diameter of high pressure HP cylinder. And C, work required for the compressor, yung total. So solution, letter A, the volume of pre-air compressed, ang ito yung unang required. So for the LP cylinder, the displacement V sub DL is equal to pi. DL is squared over 4 times L times N is 4 pi times 14 is squared times 15 times 300 over 4 over 1728. Conversion yan ng cubic inch. Kasi yung length sa DL is in inches. Or 401 CFM. So the volume drawn N is V sub 1 prime is equal to N sub B times BDL. Yan. So tinan nyo yung figure. Okay. N sub B is equal to 1 plus C minus C times P sub 2 over P sub 1 exponent 1 over N. Sorry, nabaliktad. Okay. Kata natin. So, ito na. 1/n. So, n sub b is equal to 1 plus 0.04 minus 0.04 times 56/14 exponent 1/13. Walang problema sa units. So, is equal to 0.924. Itong walang problema sa units. B sub 1 prime is 0.924 times 401 is 370 CFM. Now, measured at 14 PSIA and 80 Fahrenheit, required kasi yung pre-air. From PB/T is equal to C, the volume of pre-air is B sub A is equal to P sub 1, B sub 1 prime TA/P sub A T sub 1. No need ng conversion factor. 14 times 370 times 530 over 14.7/540 is 346 CFM. So this is now your answer. Volume of pre-air kasi ito yung nominal na tawag din sa mga compressor. Next, B, the heat transferred during compression to water around the LP cylinder. So this is the heat loss dun sa cylinder. Na process 1 to 2 is the air rejecting the heat. The heat is that thrown in plus that in clearance. So T sub 2 is equal to T sub 1 times P sub over P sub 1 times n minus 1 over n is equal to 540 times 56/14. Exponent 1.3 minus 1 over 1.3 is 743.6 Rankine. So B sub 1 prime is 1 plus C times BDL is equal to 1.04 times 401 or 417 CFM. So ito yung B sub 1 mo, state point 1. So M1 is equal to P1 B1 over RT1 is equal to 14 times 144. So included na dito yung conversion. Times 417 over 53.3 over 540 is 29.2 pounds per minute. So ito na yung mass na nag-circulate dito sa cycle na yan. Dito sa 1 to 2. Yeah. So heat transfer during the compression process LP cylinder is Q12 is equal to M1 times CB times K minus N over 1 minus N times T2 minus T1 is 29.2 times 0.1715 times 1.4 minus 1.3 over 1 minus 1.3 times 746 minus 40.6 minus 540 is Q1 to 2 is equal to 340 BTU per minute. So yan. Ito yung heat transfer during compression to cooling water. So yan. Constant isentropic process. Hindi. Polytropic process to. 1 to 2. Kaya ito yung equation niya. So, wag isentropic, so this is 0. Diba? 0 yung Q. Then C, the heat rejected during intercooling. So, 2 to 3. Yan. So, the mass of air rejecting heat in the intercooler corresponds to B1 prime is 370 CFM is equal to M1 prime is equal to P1 B1 prime over RT1 is equal to 14 times 144 times 370 over 50.3 over 540 is 25.9 pounds per minute. Kasi lumabas sa doon sa compressor, pasok sa intercooling. So, ito yung lumalabas doon. So, and the heat rejected, the Q23 is delta H23 is constant enthalpy, constant pressure pala. So, M1 CP times T3 minus T2 is 25.9 times 0.24 times 540 minus 743.6. So, Q is equal to negative 1265.3 BTU per minute. So, heat rejected. So, D, kasi lalamig yun, di ba? So, the diameter of each cylinder. So, the mass of air passing through the each cylinder is M1 prime. 29 pounds per minute. Ganun din lalabas sa dito. 1 to 2, 1 to 2, 3 yan. Yung kanina is yung total na nag-circulate. So, B sub 2 prime is equal to M1 prime RT3 over P3 is equal to 25.9 times 53.3 times 540 over 144 over 53.75. So, yan yung bago yung pressure. Iba yun sa P2. So, this is 96.3 CFM. Yung displacement ng high pressure, B sub DS is equal to B sub 2 over NB is 96.3 over 0.924 or 104.2 CFM. So, the formula naman sa displacement, B sub DH is equal to pi DH squared over 4 times 15 over 12 times 300 is equal to 104.2 CFM. So, DH is equal to, i-equate mo yan. Ito pala, linipat lang to dito. Unknown is DH, so 0.595 feet. Yan, is equal to 7.14 inches. Say, 7 and 1/4. Ito yung nominal na malapit. Ayaw ng 8. Mas malapit siya sa 1/4, 5. Okay? Yun naman to 5 size. Shop size. Or 5 size. Okay lang ito kasi approximation naman yung mga iba dito. Heat loss, hindi ito dimension ng machine. So the work required for the compressor from the LP cylinder, the work is W is equal to N M1 prime times RT1 over 1 minus N times P2 over P1 times Pn minus 1 over N minus 1. Okay, yan yung work sa compression. So work is 1.3 times 25.9 times 53.3 times 540 over 33,000 over 1 minus 1.3 times 56 over 14 is 1.3 minus 1 over 1.3 minus 1. So negative 36.9 horsepower. Ito kasi 33,000, ito yung conversion. So the negative sign indicates that the work is done on the air. Yan. So on the air doon sa compressor. Diba? Baka isipin nyo yung ambient. Okay? Since the pressure ratio for this special that is P4 over P3 is 215 over 53.75 4, same as for LP cylinder, and T3 is equal to T1, 540R, then WSP is equal to WLP is equal to negative 36.9 HP. So the total work is negative 2 times negative 36.9 is negative 73.9 horsepower. So this is now your answer. Next slide, piston speed. Okay, the piston speed normal range may be as much as 350 per minute for a small compressor with a stroke of about 6 inches to more than 700 feet per minute in large compressor, say with a stroke of about 36 inches. So dito mo masasize yung connecting rod. Yung speed nun. Di ba? Yung RPM nung sa connecting rod mo. Yan. So, this is the end of air compressor test. Ito yung test equipment. Okay? Sample. Ito yung receiver. Then, ito yung air compressor. This is the end. Ayaw mag-end. Yan.